Good morning.
Good morning.
Mm.
Do you guys have a good weekend?
Yeah, that was awesome.
Very nice. Yeah. Um, yeah, we'll give others a few moments to come in. I think how many students do we have now? Yeah, we have about 11, but usually, people start pouring in after the first 5 minutes. So yeah, it was, just carry on a general conversation. You can ask me general questions if you want, and um, yeah, we'll start in a few minutes. Okay, so when I talk about objects and stuff, and we can, take volunteers like before and start coding. Well, I'm still here. So yeah, a few minutes. Okay, no hurry. I think at 8:05 we can start at 8:05 and 8:05 between 8:05 and 8:10. We'll have enough time to cover all the material we want and also work through some interesting stuff. Um, yeah, someone asked me a question. All right. Have we covered this topic already or and so on? Okay. There's only one way to find out if I've already covered a topic. And that way is, well, I'll leave you to find out. Okay. But there is a way, right? You don't have to ask me if I've covered a particular topic. What can you do to find out if I've covered a particular or if the class really I'm not covering a particular topic, right? So it's I basically go with what you guys want, and if the students want to talk about something, and we'll talk about that. And you have no way of finding out what was discussed in class except for one way. There's one way you can find out. Do you know what that way is? Do you know how you can find out what was discussed in class? Because as you know, our goal is to just cover all of the material in the syllabus, but not in any particular plan. Because if I find that if I have a plan and I say this today we're going to cover this, by the end of this lecture we're going to cover that, and so on and so forth, it doesn't work for everyone, right? It works for me maybe because I'm the guy who made the plan, but it doesn't. I don't know how many guys does it work for amongst the students, right? So because each person has a different pace of learning, a different style. Some people will get stuck with arrays, spend more time with arrays and less with objects, right? Some people, for other people, arrays may be second nature, but they get stuck with objects. So and so it's all different for different people. So I think really the best way to progress through our classes is not to teach according to my style, but rather to teach according to your requirements. And that's why in our classes, yeah, thank you, Bael. That's how you do it. So in our classes, I know that there's a bunch of topics that need to be covered before the end of the course, and I'm confident we can do it because we're keeping good pace here, and we even have a lot of time to go and review material more than once. But we will not be doing it according to a published plan, even if I put it in the syllabus, right? I mean, in the syllabus I have this week we do that. These are just recommendations, because I can't put it in the syllabus and say this is what I'm going to do for the rest of my life, right? So I'd say, if I don't have any other plan, this is what we fall back on. But that is really the last resort. Every time we begin class, I depend on you guys to tell me what topic you would like me to cover that day, and so on. Okay, so I think that's how we go. So if you've missed a topic or you don't know, yeah, we can review the midterm, but really, just bring up concept questions from the midterm and ask in general, and we can talk about those concept questions. Okay, so we can do that. Let's not spend too much time on the midterm, right? Because we need to march forward as well. So try and make sure that we can get through the midterm questions really quickly, and then talk about more consequential stuff. Okay, so anyway, that's where we're at. We'll start in about 2 minutes, right? Eight. Let's say at about 8:10, right? 10 past 8, and I think we'll have most of the students are usually here by 8:10. So we'll start at 8:10, and then we can go at full speed, right? Today, of course, is election day, so I hope most of you guys who are able to vote will take your time. Will take the time to go out and cast your ballots, since it's very important. As we've
Is
talked
it
about.
election today?
Sorry?
Is it election today?
Well, today is the last day to cast your ballot, I think. This is November, it's the 3rd of November, right?
Yeah.
Yeah. So today is the last day, and find a spot near your home or somewhere, and then and take some time off today later. Not in my class, someone else's class. No, not during any class really. After your classes are over, just go and find a place to vote. I mean, after all, you guys took time out to go trick or treating 2 days ago. Then election is far more important than Halloween trick or treats. Oh, by the way, yeah. Okay, so that is my that was my trick or treat scare that I left out. And as you can see, all the candy in front of this evil-looking guy is gone, but on his back, nobody touched the candy behind his back. And the idea really was that I put it out there, and when the kids come around, when the kids come around um, to pick up something, I would be hiding there somewhere, and oh, do I need to switch this on? Yeah, I forgot to switch it on. All right. So I told you I had that drone, and I was planning to use it to do aerial, well, program it. But I never got around to it. So I thought I might as well make use of it for something fun. So I went to the dollar shop and got one of those masks, and I stuck it on top of the drone. It's very light, right? So and the flight controller can handle that. So I stuck it on, and so when the kids come by, I was going to stay hidden somewhere. And then when they're just about to grab one of those pieces of candy, I would get the guy to go off like that. Hey, so that's really cool. I think I really scared the wits out of a couple of them, but it was really fun. Okay. And then, the only thing that didn't work was I was I didn't have time for that. I was going to put my iPad camera so I don't even have to be around, and then I can capture a video like I do with Peter, and then edit the video later. But that was overkill. I didn't have time for that. But this was fun as it is. All right. So anyway, so I think, is it 8:10? Yeah, it's 8:10. It's 10 past 8, and then we can start our classes today. Is everybody here? Well, most of you are here, I think. Let me check. At some point later today, I might ask you to go in and, for say I'm here, do the I'm here thing in chat, so I can get your attendance down or something like that. Okay, so as usual, the plan is open. Today's my plan, if my tentative plan or fallback plan, is to talk about objects and classes. And it will be really fun because I think we're getting to a place in C++ where you can start creating not only the logic, but you can also start creating the objects, the things that the logic operates on. Yeah. So far you've only been able to play with data that's already available to you, raw data that's available to you, like integers, characters, floats, doubles, strings, right? And objects like cout. It's all made for you by someone else and given to you. And then you just pick it up, and then you create your own logic, right? Your program, your logic. And then that logic would manipulate the objects or things that are given to you. And once you're reasonably comfortable with creating these pieces of logic that operate on the objects, the next question in your mind naturally is going to be, well, it's really cool. I'm now able to manipulate things. Now, how can I go around creating the things, right? So now that's what we can look at today. Now, those of you who are missing lectures and missing classes, and you are unsure of what's being discussed, just look at Biles. Was it Bile? Someone made a point here. Yeah, Bile posted a note. Just look at that, okay? So that is exactly what you need to do. Just watch the lectures. And we are, in fact, posting recordings of our lectures on YouTube. It's open to the whole world, really. Not so it's published and open. So you can just click on it, and watch it. The only hassle I see is that, except for Zach, Zach is the only one. Is Zach here today? Zach, are you here? Oh, wow. Zach isn't here. But Zach was the only person who took the trouble to tag these videos with, hey, 2355, Daniel's program, or and so on, right? So please go ahead and do this so that other people can and can also benefit from these lectures. I mean, that is if you think the material is beneficial, right? If it's not, you don't have to. But I think most of the demos you guys are giving are definitely um, very, very beneficial, very useful to the other students, right? Even if it's a very simple program, you will be surprised. There's so many students who would totally benefit from your simple programs. Okay. Um, So yeah, I was thinking today, if there's no other plan, we'd talk about objects and maybe create objects. So I'll take a volunteer from class, someone who hasn't been up on the stage before, right? So I'd like to take a volunteer again. So feel free to pipe in the chat window. Just say I'd like to go. That's fine. I'd like to go, and then after that, I look at the list of students in the chat window, and I'll just pick one randomly, okay? So my criterion for picking one of you is just going to be who hasn't had a chance so far, right? There's only 9 more classes to go, and these opportunities are going to be very limited. So this would be a great time for you to just say, I'd like to volunteer. And if you don't know what that entails, you can take, who was it last time? Was it, Alexis and Chan and a few other people? Right. Thank you, Mohammed. Yeah. Is this a YouTube channel to our classes, or is it a YouTube channel to some movie or something? Is that the
No,
channel for our
it's
classes?
linked for our YouTube channel,
Oh,
an
yes.
online.
Okay. All right. I just wanted to make sure, in case you're sharing YouTube channels to the news or some movie playlist. Okay. Um, anyway, yeah, Alexis and Chan, and I think one more person. We managed to have 3 new students demo their code last class. So you would have a similar opportunity, which means they were all, check with Alexis and Chan. I think well, they certainly didn't look like total newbies when they came up here to code. Looked like they have some practice at the very least, I would say. But from their Reddit posts and from the questions they were asking in the forums, I was totally misled into thinking that they must be total newbies and they didn't have any idea what the hell is going on, and they're, on the brink of dropping the course. It turns out that's not the case, right? Because when they came up here, I could see that they actually did have a reasonable level of experience. But the point is that I was prepared, and everybody else in class is also prepared to have anyone will volunteer, even if you didn't have any experience, right? So even if you haven't coded so far, I think in 2A, right? Even if you haven't started coding and you didn't do any of the quests, right? You're at quest number 0. I think uh, I don't think I'm wrong, okay? Maybe in a very few cases. It is still possible to ace this course. I mean, get an A plus if you just set yourself to doing all the quests from now, get to quest number 9 there, and after quest number 9, automatically quest 1 to 4 will get unfrozen. You go back and get the points for your quest 1 to 4 also, which is, also it's very, very easy to do. So you ace your quests, and if you ace your quest, I'll give you another chance at the midterm. If you want another chance at the data representation quiz from day 1, I'll give you another chance. But if you ace all the quests, okay? If you not ace means you don't have to get full points in all the quests. If you just get to the password in every quest and get up to quest number 9, and then I get a chance to look at your code, right? So when you get to quest number 9, well, I look at your code other way at other times too. But if you get to quest number 9 and ask me, I look at your code in a little bit more detail, right? So and then if it seems to me that you're really genuinely interested, you're trying to put in some real good effort there, I'll say, hey, it's clear that you've aced the quests, but with the quests alone and the other points you've got, you only end up with a B plus, right? But I really think you should get an A plus because you have it in you to get an A or an A plus. So I'll say, go ahead now, right? I'm going to unfreeze the data representation quiz and the midterm quiz, go back and do it from 6 p.m. today. And something like that, okay? And then you get an opportunity to get an A+, even though you haven't even started class, working on program. So it's still possible, right? And it's not going to be possible for much longer. I think if I say the same thing to you, I cannot say the same thing to you in 2 weeks' time, because I think in week 8, if I tell you you can start now and still get a chance at A+, I don't think I'd be as correct, right? Because it'll be very, very hard. And it's still possible for someone who's, who already knows C++ and is just here to get a, something on the transcript. They can do it. They can get into this class, let's say 2 days before the final, right? Even 2 days before the final, they'd be able to do all the class, and I'll give them a chance to do the midterm and the data quiz, and they finish it all up. So it's pretty much like testing out of 2A. Right? So meaning that I know the material in 2A, I want to go on to do 2B, but I don't want to do the whole class. So I'll just come in on the last day and test out of it by doing the midterm and the data representation, all the quests, okay, in a matter of a few days and the final. I'll give you the opportunity, but it won't be possible. Thank you, Andrew, right? Andrew volunteered, but obviously he's saying the same thing as I did. Okay, Andrew is saying that he'll be happy to take the screen and do something if nobody else wants to, and that's what I prefer too, right? Because Andrew, as you would all know by now, he seems to be although he also started at the but I think he had a little bit more time early on to set up the Slack and do more work. So I think he's more familiar with some of the coding practices that we talk about. So certainly Andrew, I think Andrew and Daniel and Giorgio and a few other people, right? Certainly not Lex and Chan, who were here last class. Okay, you guys don't get to go on screen. But other people get first preference, and nobody else volunteers. Yeah, then Andrew. Yeah, I know Andy set it up, but you guys were pretty deeply entrenched in class and also coding up, and I think you also had an opportunity to come up on screen before. So let's give the other folks a little bit of a chance. Okay, so I'd like someone to volunteer. And so here's what we will do today. So a lot of you have turned up, which is good. Okay, so here's what we're going to do. I'd like to, if there's nothing else to talk about, I'd like to talk about objects and the way I'd like to do it, and subject to change, and we'll morph the way that we handle this as and when we do it, right? When you're coding and I'm coding with you, so we'll just adapt. But my initial plan is to create some kind of object and play with it, and maybe we'll even create a pet object, it's. I think the pet class is something you have to do for quest number 5 or 6, right? So you have to create a pet class. We can do it, but we won't do the pet class that is required for the quest, but we can do another pet class, a pet class that is similar, so that you can take that and then massage that into shape for your quest. You can do that too. So we can do that, or we can do some other boring class like an employee or a manager, or anything else that you guys come up with. If you have an idea for another kind of class or an object that you would like to create, we can do that too. So there's a bunch of different options, many options actually. So take the screen, chime in the chat window, saying, yes, I'd like to go, right? I'd like at least 3 or 4 of you to say, yes, I'd like to go today, right? And do that. And remember, you don't have to have anything to go, right? All you need to do is just have that little bit of courage to say, I'm happy to go up in public on the stage, right? From the comfort of my home, right? From the comfort of my home, I'm happy to go up on the stage, the virtual stage, with absolutely nothing and no idea what the hell I'm going to do. I'm happy to do that, right? If you have the courage to do that, you will have the courage to do anything in life, right? Because you're saying, I'm going to go up against something that I don't even know, right? I'm going to take a chance. I'm going to take a chance because I know that's not going to kill me, right? And what doesn't kill you make you stronger, right? So I know it's not going to kill me, and I'm going to take a chance and do it. Even though I have no idea what I'm setting myself up for. What's the worst that can happen, right? So if you have that attitude and mindset, you pretty much raise your odds. Muhammad, thank you, right? You raise your odds of succeeding, not in 2A, succeeding in life. If what with that attitude, you raise your odds from, let's say it's 0.1% to all the way to 95%, 95%. From 0.1%. That's like 950%. 900, yeah, thank you. I got so many volunteers now. All right. So you just raise your odds by that much because all you're saying is, I'm going to try. I'm going to try, right? Because if you, if you don't try, you're not, I can say with 100% certainty, you're not going to succeed. You're going to fail. Failure is guaranteed if you don't try, right? But success is not guaranteed if you try. Okay, so you think about that. Success is not guaranteed if you try, and failure is guaranteed if you don't try. So you have two statements that are absolutely true, right? It is guaranteed to be true. Right? Think back to your philosophy courses, right? You apply deductive reasoning, not inductive reasoning. Okay, it's deductive reasoning. Deductive means that if the premises are true, the conclusion is guaranteed to be true, right? Not like induction. So think about that. I've given you two statements that are, yeah, I mean, you can send me email sometime this week, right? This week. I think after this week, it'll be harder for me to go back and tweak scores. All right, so send me. Yeah, so two statements. If you don't try, you will not succeed. That's true, right? Of your own effort, right? You may succeed, because as a byproduct of someone else's success. But if you try, you may succeed, right? Which is also true. All right, so I have three people. The first person to volunteer today will go first, and I think that is Muhammad. Muhammad, how do you pronounce your name? Is it Muhammad or Muhammad, or how do you pronounce your name?
Actually, it is Muhammad Rizo, but you can call Rizo.
Rizo? All right, yeah,
Yes.
thank you. Rizo is going first. So at any time you are ready, pick up the screen, and then we'll start talking about an idea, right? In fact, let's go with pet. If nobody else has any other idea, we'll just go with the pet class, and start.
Can you see my screen?
Yeah, I can see your screen. Can everybody see Rizo's screen?
Yes, we can.
Okay, and what ID is this, by the way? Is it VS Code?
It's code blocks.
Oh, I see it up there in the title bar, code blocks. Okay, so I'm not familiar with this IDE, so you may have to guide me. But I hope it does automatic indentation and things like that for you, so we don't have to mess with those things. Okay, is everybody ready? I can start giving you a really quick introduction to objects, and then what Rizo is going to do is going to create an object for us. It's called a pet class. He's going to create a template for an object. And then we'll take that and then add on to it. And Rizo, if it's possible, let's just work with this code through you and then through the next person and other people also, and also save this so that we can come back to it if necessary on Thursday and take the same code, and we'll see how long this code lasts us in a useful way, meaning that we can keep on adding to it. At some point, it'll become so tedious to modify this code that we'll say, all right, we'll start a new project for a new concept, right? But until then, we'll use this one, okay? So just make sure that this code is not, you auto-save or whatever it is, and preserve it so that we can publish it and have other people pick it up. All right, so if there's no other ideas, we're going to start now. So what we want to do is to create an object, but in order to create an object, we need to create a template. So as you know, so far, we've been able to create integers, create characters, right? So, Rizo, we're going to delete all this in main, but as I'm, create a dummy integer in main and say, this is how you create an integer, and then we'll delete the declaration, right? After the brace in main, just say enter. Yeah. So say enter, hit enter key. Yeah, it does actually. No. Enter key, the return key. Yeah. So it's indented things properly. Now just
Okay.
declare. Yeah. Enter. Yeah. Okay. Now int an, right? So I type int an space an. Yes, I mean yeah, whatever. A so, and yeah, fine. So whatever. Right. Yeah, I meant the letter n, but for a number. But
Okay. And okay.
yeah, lowercase is usually good for local variables. Okay, semicolon right there. Okay, now when you make a statement like that, the compiler knows that an integer is 4 bytes. It used to be 2 bytes, now it's 4 bytes on most architectures, right? 4 bytes, and it allocates space in memory. Somewhere in memory, it allocates 4 bytes of, 4 bytes of space and memory for you. Every time you say n equals 10, it's going to take the value 10, which is, what is 10 in binary? 0 0 0 0 1 0 1 0. Yes, that's 10. 8 plus 2, 10. So every time you say n equals 10, it's going to take that bit pattern 0 0 0 0 1 0 1 0 and put that in the 4 bytes that it has reserved for n in memory. So it's somewhere in memory. You don't know where it is, right? And that's a beauty, right? We don't have to care. Unlike in assembler, when you're programming with machine code, in machine code, you need to know every single variable. You need to know exactly where it's stored in memory, so you can go there and change the value, right? But with a compiler, that's been taken care of. Because how did that happen? Because people were programming in assembler and machine code first, like John von Neumann, right? And then after a while, they realized that it's very, very tedious doing all these translations. Every time I want to update the value of n, I need to look up in my notebook, where did I store n in memory? Oh, yeah. Byte number 1,342,000, right? Okay, so I want to change the location of byte number 1,342,000, right? So it gets really tedious looking up the value each time. And then they realized, well, you know what? Am I really being a human being when I do these lookups? This is a very important concept to understand, right? So what we're trying to do here is trying to draw a fine line between what a human can do and what a machine can do, right? Because and that line is getting blurred, more and more blurred with every passing day, right? As AI gets better and better, it is able to take on more of our tedious and boring tasks away from us, right? And I made this point several times, even in classes when I was teaching face-to-face. I'm pretty sure it must be recorded in a YouTube video of one of my past sections on our channel. But really, there are people who say, oh, I'm scared of AI. Well, not scared, right? And they're anti-AI, and they say, well, these machines are have come out there, they're taking over our jobs. Cashiers and grocery store checkout people, they're all being replaced by machines. This is really bad for humanity, right? It's bad for humanity because machines are taking over everything that we're supposed to do. And I listen to these people and I think, how this is really a very I shouldn't say stupid, but uninformed way to think about these things. Because if I look at the very same people who are saying these things, saying that machines should not take over human jobs, but they don't think twice about using as a washing machine or a dishwasher. Or they don't think twice about using their phone and talking to their cousin or brother or mom and dad who are in New York or somewhere on the East Coast, right? If they are so much against technology, what they should really do is basically, get out of their home, walk to New York, okay? Not even take a bus or a train, right? Walk to New York, give their message, hey, could you come over to Palo Alto and switch off my, the light in the living room, okay? All right, and then, so why do they use technology? They use technology because technology allows them to focus on things that they can do as a human, which really is to enjoy life and create new content that other people can take pleasure from, right? That's really what humans are trying to do. And if we embrace technology, it's because technology lets us do that or enables us to do that. So if technology can come in and take out all the grudge work, not grudge work, what's the word for drudge work, or so if technology can come in and take out all the routine and boring stuff from us, Yeah, grunt work. Thank you, Augie. Yeah, if they grunt, yeah, that's what I was looking for, right? So we would gladly let it do it. And that means that we would have infinite vacation. Right? There's always a chance that, the fear that people say, oh, if I don't have any work to do, that I won't get any money and then I'll be starving. Yeah, that's where, it's good to live in a governance in a country where even if you don't do anything at all, as long as you're not disruptive and go around killing other people or doing bad things, the government says, we'll give you some basic, we'll take care of your basic needs as long as you're okay with that. And so that way you can still be a fan of technology and do all, and embrace all the great things it's bringing to us, and not anyway, I don't know where we're going with that. So anyway, technology is absolutely great, and yeah, these variables. I don't know how did we even start talking about that? Anyway, so classes. All right, so we're going to start creating these classes. Oh, I got a bunch of messages here. Yeah, okay. All right, so we're going to start creating these classes, and the way we're going to do that is since nobody has piped up, we're going to go with the pet class. Okay, we're going to go with the pet class, which has the added advantage that you can now use the pet class as your starter code for your quest number 6. I don't care. It's quite easy. Okay. All right. So as you can see, this is how. The compiler sets up memory for you and everything, right? So the compiler takes care of these things. Grunt work, right? It's grunt work. And that's how the compiler was born. Okay, the compiler was born because we wanted to save ourselves the grunt work of mapping these variables to the memory locations and finding, and we see that that's all of that is automatic. I can get a machine to do that. Why should me as a human waste my cycles in figuring out the all these nitty-gritty details about how to convert my program into machine code when it is technically possible for a brain-dead automaton to do exactly the same thing. I could get the machine to do the conversion, the translation for me, while my precious human cycles could be devoted not to that, but to think about the logic and the creative aspects of what I'm building, which is far more pleasurable, really. And also, if you think about it, a great deal more useful to the end user, right? Because, that's where the value of the product comes in. So that's what we're trying to do. So the compiler will take care of these things. Now we can create these strings and integers and so on, but we want the ability to create more sophisticated objects, not just these primitive types, right? So we're going to go ahead and create an object called a class called a pet, which means, right, we're going to tell the compiler, hey, dear compiler, you know how to create an integer, you know how to create a character, you know how to create a string. Now I will teach you how to create a new object called a pet, right? A class. I'll create a template, a template. I'll create a template called a pet, and I'll give it to you. So every time someone comes and asks you, give me a pet, you can just take my template and stamp it and create the object and give it to them, right? So you're going to create a template. So we're going to create the template in 2 different ways, and we'll slowly morph here from C to C++. Okay, so we're going to create it in C, and then I'll show you how to convert that into C++ using some of the C++ features and what those extra features give you, right? Many times people, I've seen students in the past who are just introduced objects in C++. And unfortunately, that happens even now in some other ways of teaching C++, not my style, other ways in which you just get told, this is how you create an object. Classes like stuff like Java and Python, right? So this is how you create an object. Go ahead and create an object, right? But there are certain nuances to do with the motivation for things that we use in objects like public and private and protected, which you'll never get to truly appreciate until you come at creating an object or view the perspective to view a class, an object from the C side of things, right? So meaning closer to the machine, closer to the assembler, right? Come from there to look at an object, you get a completely different perspective of the object than coming to look at the object from the other side, from the outside, which is like Java and Python and JavaScript. They look at the object from this side, you get a different perspective, which is a usage perspective and how to use the object. That's the perspective you get. But I think that your grasp of classes and objects will be much stronger if you get both perspectives, right? You get to use the object from the outside, like in Java and other things, but you also get to look at the object from the inside, from the machine, from C, right? And then you get the full picture of the C, both the internal picture and the external picture. When they both come together, you get a total view of the object, right? That is comprised of the two internal and the external, and that means that you are now set up to basically do anything you want, right? It gives you full power. It gives you full power. How about that? Okay, so go up to above the declaration for main, right, under namespace standard, and now we're going to create a template, right? A template for stamping off new things. So we're going to call it and a template is basically a structure. So we're going to call it a struct. Okay, a struct goes all the way back to C, right? Yeah, use a blank line after namespace. It looks better usually, right? Yeah, blank line after namespace. Yeah, yeah. Okay. Struct and space, and then give it a tag pet with a capital P. Okay, right. Space and then open brace. Open brace, yeah. Oh no, brace. Yeah, curly. Okay, hit enter. Okay, now give yourself a blank line. Yeah, thank you. Very nice. You're thinking ahead. I like this IDE. I think most IDEs do it now. It's actually quite a while since I used an IDE. Most of my recent code I've just been doing in an editor. So I've actually forgotten. It's surprising how quickly you forget these things. The fact that you automatically get a closing brace and a semicolon for structures, right? I knew it happens for functions and some other, and maybe for classes, but structures also is very cool. Okay, a structure, which is abbreviated to struct in C++, basically means here I'm going to define a package, right? It's not a single variable called an integer, or character. I'm going to create a package, right, with a lot of stuff inside of it. And every time someone wants an object of that type, just take that template that I've just created, a structure, and stamp out, right? I've told you how to do it, stamp out one more. So that's what we're going to do. So inside of the pet structure, create a variable or a member, it's usually a member, called name, and it should be a string, right? So say space, indent 4 spaces. Yeah, indent 4 spaces and string name. Yeah, thank you. Yeah, indented in, semicolon, and then 4 spaces before. Yeah, and then
That's all?
So 4 spaces before the string. Indent the line. Yeah. Okay, yeah, that's good. Are there any other properties that we could put in? Yeah, okay. All right. Say a string favorite food. String favorite food. Hey, Muhammad, are you? Is it Rizzo? I assume you're not in America, in the U.S. Is that right? Or at least you didn't go to school in the States?
Yes,
yeah?
I am international student.
Okay, all right, because you spelled favorite with with a U. Actually, I don't know how you spell favorite now. Now that I'm confused. In America, do we pronounce it without the U? I don't know. All right, okay, great.
Yes.
So we got these two things there: name, favorite food. What else? Do we want a numeric variable there? Does anybody want a numeric variable for a pet? Can you think of something that would have a number for a pet?
Age.
Age, okay.
Yes.
Yeah, say age. Yeah, int age. Yeah. Okay, great. So, all right, thanks. I think that should do for now. Now, what Rizzo's done is he's basically created a new data type, a brand new data type, just like integer, right? Just like integer, just like anything else that you've used so far. Now, the beauty is that now you can declare and create a variable of that data type, just like anything else. So go back to your main, get rid of the int n. You don't need that int n, but instead of the int n, create a pet called myPet. Yeah, okay. Now, let's say Now this MyPad doesn't have anything inside of it, right? It is just a blank MyPad. You know, it has it has what happens there is internally when the compiler sees that, what's going to do is actually, can you see me highlight? Hang on. Can I highlight your screen? Oh, I can't. Okay. Well, when it sees line 13, right? When the compiler sees line 13, it says, oh, the programmer wants to create an item, okay? Usually this programmer creates ints, chars, and so on, bools, right? Oh, this one's called a pet. How do I create a pet? Do I know how to create a pet? I know how to create an int, but do I know how to create a pet? Oh, yeah. Okay, right there on top, line 5 to 9, the programmer told me how to create a pet. Okay, so the pet has, inside of the pet, it has three things. It has a name, which is a string, and it has another string, favorite food, and an integer age. Now, I know that strings are stored in 24 bytes in memory, right? It's actually 24. I think it's around 24, 25 bytes. No matter how big your string is, the object itself in memory is stored in 24 bytes. And the reason is really because, you know, the actual string is stored elsewhere in memory. It stores a pointer to the string inside of this object. So that's what this has, right? So 24 bytes for the string name, another 24 bytes for the favorite food, and let's say, how many bytes is an integer on most architectures? 4. Thank you, Nee. Right. So, right, 24, 24, 48 plus 452. So it knows, the compiler knows every time Rezo wants to create a pet, just like for integers, it's set apart 4 bytes. Every time you want to create a pet, the compiler will set apart 52 bytes in memory, right? 52 bytes, and they are structured in such a way that the first 24 bytes is the name. The second 24 bytes is the favorite food, and the last 4 bytes are the age, right? Now, every time a pet is created or referenced, that is a block of memory that it refers to. Okay, so now let's go ahead and create a name for this pet. Okay, so let's say my pet. How do you access the name part of that pet? So in C, what you do is just say name dot pet, my pet dot name, right? And a blank name, a blank line after the declarations before you start the code, right? So this is logic, and declarations usually nice to separate with a blank line, right? So after the declaration, insert a blank line. Thank you. Right? My pet dot name equals, and then give it a name. Give it a name of your choice, right? Or maybe someone else can tell you if you're stuck, right? When you say come up with a name, it's harder, right? Or you can use one of my past students' name generator and create a name if you want. But you can call it anything you want. You can call it Rezo, Peter, Andrew, Alexis, Flavio, whatever. You can give it a name. Give it a name. Laska. All right. Okay. I think you need quotes around it because it's a string.
Okay.
Yeah. Okay. Great. Okay, now also give it a favorite food just like that and set its name, set its age. I don't know what kind of animal Lasco is. Is it a fish or, oh, it must be a carnivorous lion or something like that. I don't know. All right, so neat. Okay. All right, and then what is its age?
Stakes 4.
All right, okay, 4. Now you will find that you can access the pet in exactly the same way as you've been accessing any other data type in the past, except that, if you want the name, you would just qualify it by mypet.name, mypet.favoritefood, and so on and so forth, right? So now give it a blank line to separate the sections again. Blank line after that, and blank line after that. Now insert a bunch of cout statements of your choice, right? And print out the quantities or whatever you want, right? Maybe just print out the name or name and age and so on. Or you say, my pet Laska is 4 years old, right? So what would you do? So you say, my pet space You need a space after my Pat, because otherwise the name will run into it.
Yeah.
Yeah. Yeah. Is how many ever years old? You need a space, yeah. Is everybody okay? Are we all on the same page? Yeah, is everybody following with Rizzo?
Yes,
Great, great. Awesome. All right. Now, you may need to do a couple of basic fix-ups. Oh, actually, I think you're good, right? You need an end line, I think.
Okay.
I think this should be good to compile and run, but before you run it, let's ask to see if everybody can run this in their head and thereby confirm that it goes, okay? So everybody, if you think there's issues, just, yeah, thank you. All right, so you got some comments there. Okay, so look at your comments, make any fix-ups you need. Let's make sure that everybody can run it in their head first before you run it on your IDE, because it's important to run it in your head first. Okay, and everybody run it in your head, and if you think that it'll work without any issues, just type in the chat window saying looks good to me, right? Just like Augie said, everybody, if you think it'll run in your head, say looks good to me. Sorry?
No. It's just sound.
Yeah. Giorgio, we'll get to a struct in class, right? A struct is basically the C version of a class. Obviously, because it's in C, you don't have some of the things that C++ brings into the picture, like scope and privacy and things like that, protection and so everything. A struct is basically a structure in C++ where everything is public. Right. So when you go to C++ later, very soon, in about a half hour or so, we'll be doing the same thing in C++, where you now have the option of saying, my pet has a bunch of these properties. It has a name, it has a favorite food, and so on. But random people can't just see it. Right. But right now, you see here in main, which is a user of the pet class. Right. It's a user of the pet class. It didn't create the pet class. Right. Because for all we know, here Rizzo created the pet class, but maybe Rizzo just created the declaration and didn't do the main method, right? And maybe Giorgio or Alexis or someone else, right, picked up Giorgio's code, no, not Giorgio's code, right? Rizzo's code, and then started adding. So which means that you're using the class created by someone else. Yeah, right. If that's the case, you won't be able to access these guys directly by saying, oh, give me pet.name and so on, because the user, the creator, Rizzo might have thought, well, I've created a class and there's lots of things in here, but I don't want these things to be visible to the outside world because they constitute the magic of what's going on inside. If I allowed people to look inside and change these parameters, most of the people don't even know what the hell they're doing. So they'll go and make these bad changes and they'll break the object, and then eventually they'll blame me, right? So how many of you know this, right? You've bought objects on Amazon and things like that, and we think we're so clever and we want to customize the object, and we take it apart and say, all right, I'm going to move these screws and bolts here, and then we switch it on and it doesn't go, it broke, right? And it didn't, and when it breaks, we look at the manual, and the first page of the manual says, do not open this and take this product apart. It needs to be assembled by a master craftsman, right? If you take it apart, the warranty is void instantly, right? Like your iPhone, right? Warranty is void. So, so someone might have designed a product and said, well, this product can work magic in the hands of users, right? This iPhone really is magic. If you think about it, it is really magic, isn't it? Because it lets you talk to people like instantaneously at the speed of light, right? So we're able, it's magic. But however, it's magic only because a lot of the magic is hidden away inside of the metal and the glass, and people can't go opening it and poking in it with screwdrivers and saying, hey, I want to customize me, I want to change, I want to resolder the whole damn thing, right? You're basically fucked at that point. unless you know exactly what you're doing. So that way, these are simple objects. For simple objects, you can say everything is public. And, I'm not doing anything of great consequence here. Anybody can come and take a look at this, and right. But when you get to doing more complex objects, you will get into the mindset, the mode where, okay, there's some of this object that needs to be visible to the outside world because they need to go and tweak these parameters and things like that. There's a whole bunch of the object that I don't want the external world to see, not because I'm trying to hide it from them, but really because most of the outside world, most of the external world, you'll find out, right? They don't know, right? They don't know. They're not, I shouldn't say intelligent, right? But they don't know what is, as good for them. No, they don't know the nitty-gritty details of computer science to be able to bend the product to their own liking, right? Even if they knew, most of the time they end up making a mess, right? Again, go back to the, I don't know, maybe some of you were not even alive when MySpace was the dominant social platform, right? And back when I was, right? So, so they just let people go ahead and customize your pages and do everything, right? GeoCities, and because most people don't know, right? They're not UI designers, they're not computer programmers. They just create a whole hodgepodge of nasty looking pages, right? Pink here and blue here, and people say, oh my gosh, that is really, wearing my eye down. I'm going to go away from that page. So the products fail. And the problem is you can't, so if I bought the iPhone and went in and tweaked stuff and it didn't work, I can't return it, because then I can't say it's someone else's fault to give me a product that didn't work. No, they gave me a product that worked and also gave me very clear instructions saying this will work to our specifications, as long as you don't go around, and screw around with the inside, and if you don't know what you're doing, right? So that way, Rizzo, who's created the pet class, maybe he creates another class tomorrow, right? 10 days from now, maybe he creates, self-docking module on a rover. Okay, there's a satellite. And that's going to have so many parameters inside, which, ordinary programmers not only should not know or should not need to know, really they don't want to know, right? That is the more important thing. It's not like you're stripping away the power from other people. Really, you're giving them the freedom not to be obsessed or not to be burdened with the details of what you are creating. So that is the beauty of object-oriented programming, because you're telling other programmers, I can enable you to become your best. I can enable you to achieve your dream. I can let you do what you want, be your best, because I can take away from you all the grunt work, right? Like, and Giorgio said, I can take away from you all the grunt work and all the nitty-gritty useless details of having to use my product, which is an enabler for what you want. Does that make sense? That is how greater and greater things get built in computer science, right? So you build greater things by doing something, and then only making a small bit of it visible for other people to be able to use your product to achieve their goal, okay? That is a mark of a successful product, whether your product is a complete product like an iPhone that other people use, or whether your product is a class, right? With a class that, or data type, that is also a product, right? You may create a really sophisticated data type, that's a product. And that data type itself may be worth billions of dollars. I know people that have created sophisticated data types that got purchased, right? So what that means is that, so you're going to cleverly and tactfully hide objects, parts of the objects, and expose only a certain part, and that part is sufficient for other people to say, right, good, Rizzo's given me a product which I can use without having to learn all the nitty-gritty details. And you'll find that is the greatest pain point when, later on, when you are going to develop your own product and you say, well, I want to do this, I want to do this, I want to have, drag and drop here, or, I want to sort this in a certain time and complexity or something like that. Most of the time in engineering, what do? You don't immediately start coding. You're going to go around and start looking. That's called, literature search, right? Research. You're going to go look around, go to Google and say, I want to do this. Is there an existing library, right? Has someone else already done it? And so I can just borrow their code. And chances are 99.999% of the time, you'll find it. You'll find that someone else has done it. So and the crazy thing is that you won't find one product, one library. Suppose you want to do something, right? I want to do automatic shading of my graphics objects. You find like 10 different products in 10 different libraries out there. Unreal, Unity, and what's this thing that that Fortnite uses? A completely different engine. I don't know. I forgot. Epic.
Fortnite's on Unreal. It's made by the same company that makes Unreal.
Oh, is it?
There's also Godot.
Yeah. So there's so many different engines, right? How do you decide which one to use? So here is the criterion that most engineers use. Oh, I don't know. I shouldn't say most. What I use is that I look at these products and I say, well, all of them do what I want, but which one requires me to do the least amount of work to understand how it does it so that I can use it? Right? Because obviously you don't want to go and use something that you don't understand, because how do you know, right? Oh, well, I also display a pretty picture on your screen, but while the picture is displaying on your screen, I'll also go and format your hard drive. Okay. So you want to understand what they do and things like that. And if the source code is available, you want to do a quick look over. You don't have to understand all of the source code, but usually what you do is just glance through it really quickly to make sure that they're not doing anything, crazy ass and dangerous, right? If the product is from a less than reputable source, not less than reputable, you're never going to use that. But if from a source where when you have a reasonable suspicion that maybe they're not doing it the best possible way, right? So yeah, thank you. Anybody have a question?
Anand, I was just thinking, like, could you say a very simplistic analogy would be, let's say we wanted to make something and we're using a screwdriver as a tool. We don't need to know how the screwdriver is made, or we don't have to make the screwdriver ourselves, but we can use it. Same kind of idea on a simple scale.
Thank you. That was Andrew, right? Andrew?
Yeah, that's Andrew.
Yes, thank you. I think that's a much better analogy. Probably, you should have probably gone before me. It saved a lot of time. Yes, thank you. Yes, it's basically you don't need to know how to create the pet object or a screwdriver. You just need to know how to use it, and that's what. And by making it available for people to use, you're letting them focus on their own creative streams, not on yours. Okay, so if everybody's okay, go ahead and run it, and then we'll see if it works as we expect it to.
Okay.
And after that, we'll go and make some more changes.
Can you see the code?
Why is it taking this long? Is it? Yeah, same thing happened with Daniel too the other day. Why is it taking this long to build your? Oh, it actually finished building. It just didn't see the. Oh, for you build and run are two different. Yeah, of course you're an IDE. Okay, I thought you were running it also. Run it. And let's look at the console. Where's the?
Can you see my console?
Oh, that's why your console is not integrated into the IDE.
Yes. I should see it.
Can you dock your console? Can you dock your console? What happens if you drag the console in here and we can't dock it? It's a DOS console.
Can you see it now?
Now I can see it. Yeah. Anyway, it works. So you see that line, my pet Laska is 4 years old. So it actually works, right? Just like a regular item. You just ended up using it and it works just as well, right? So let's go back to your code and we'll try and make some changes, right? Okay. Now, let's take this object and turn that into a C++ object, because now let's assume that, let's assume that this pet belongs to Rizzo, okay? This pet belongs to Rizzo, and only he knows that his lion or tiger prefers meat, okay? And he doesn't want someone to go in and take the pet object and reset favorite food to lettuce, right? So what happens if I instantiate Rizzo's pet and I say my pet dot favorite food equals lettuce or cabbage, right? And and it happens to be a lion or a tiger. So Rizzo wants to protect it. He wants to make sure that other people cannot go and change these things willy-nilly. Okay, how does he do that? So you can do that C++. Now C does not give you a way to do that. C++ gives you a way to do that. Okay, so we'll do that. Now go up to your struct and declaration, change struct into class. Okay, now if you say class instead of struct, the semantics of the privacy in C++ just become opposite. I think it becomes opposite, right? It goes from all public to all private, or maybe it goes to all protected. I think, that's something we need to, I forget that, right? We can confirm that very quickly when we start running it, right? So now compile it and run it. Let's see what message we get from the compiler. Okay, compile it and run it.
Okay.
Okay,
Uh,
there, you see the error message?
yes.
It refuses to compile because the compiler says, hey, name, favorite food, and age, you can't access it from outside of the class. Those are private. Okay, so if you don't default, if you don't qualify those names explicitly in the template, this is called the template, right? Line 5 to 9, that's a template, the boilerplate for how you create a pet. If you don't qualify the names explicitly, by default in C++, they're all private. In C, they're all public. Okay, that's something you need to keep in mind. Now let's go ahead and qualify it. Okay, so at the top, not there, right? So that's just a template. You can't assign stuff there, by the way, right? Unlike in Java, in other languages, you can actually make assignments there, right? And because it's I don't know if that's I don't know if I like that or not, because what happens is that if you have assignments there, then the compiler knows that when the object is created, it'll run those assignments also, right? In C++, everything is neatly compartmentalized, right? You just create the template there, but the actual assignment will happen elsewhere in something called a constructor, which we'll also get to very soon, okay? So after the brace, the opening brace, after the opening brace, not
Here?
there, pet class,
Uh-huh.
enter, hit enter. Okay, now by default, everything is, hit enter. By default, everything is private, isn't it? Now we're going to make sure that all of these are public, right? So enter public, P-U-B-L-I-C. And then, colon, not semicolon. Colon, shift.
Yeah.
Oh, it's funny. It didn't auto indent it properly. Now, can you drag the public keyword all the way to the left margin? Yeah, okay. That is usually one way. Well, I don't know, in Xcode, that's fine. You can have it that way if you want. But in Xcode, you actually have public lined up against class. Yeah, the reason for that is because you tend to have more variables than the tag, right? So if you have it right there, then it is combined with more lines starting at the same column. Whereas if you put it there, the more lines are there, so it's more clearly indented. I think that's a rationale for putting it there, right? Unless you extra indent your variables after that. Now compile and run it. It should run just like before. No, exactly like the way it ran before.
Can you see?
Yeah, I can see it. So you see that now?
Yes.
Okay. Now go back to your code. Go back to your code and try the same experiment again, except only name, let's say, only name is public. You want to make your age private, right? Or name and favorite footer. Yeah, age only is private. Okay, so before age, give me a blank line. And then insert a qualifier, just like public. Now you say private, right? Yeah. Now above that, I can say private. Okay. Now again, it'll fail to compile because name and favorite food you can assign, but it'll say you can't assign something to age. Does that make sense? Was that a good experience, experiment for you guys?
I think so.
Okay, so can we move forward?
Can I ask a quick question, I guess?
Yeah, sure. Daniel?
Momo, sorry.
Momo, all right, yeah.
So I think, so we put age in private, and if we wanted to see out age, would there be a value in it? Like, is there a way to set the value of age so it's 4 and it's like locked in as private as like 4?
Yeah, totally. Yeah, we'll get to a place where now what we're going to do is, now because they're all private, make them all private. Oh no, leave it like that. Leave it like that. Okay. So now what we're going to do is create ways, Momo, to go and set those variables. Now, so here again, going back to the whole idea and the motivation for C++, just because Rizzo said name and favorite food are private, random people can't come and access it, doesn't mean that he's not going to give them an opportunity to change these values. Momo says, no, I want to change the name. I want to change the favorite food, right? But Rizzo says, well, okay, you could still use my class and I will give you a way to change it, except it's not, you can't change it directly. I'm going to give you a gatekeeper, a worker, right? Who's going to stand at the gate of my pet house, right? And anytime you want to change the name, give your preferred name to my gatekeeper. And my gatekeeper will look at the name and say, okay, well, this name looks good. I'll go and set the name. So the gatekeeper has the ability to set the name, but if you give the gatekeeper some random, badass name, he or she is going to say, no, that name is not valid. I'm not going to set it. Okay. And then reject that name. So that way, Rizzo has now protected his class by saying it's got some private stuff in there and nobody can see, but still people can manipulate it because I've provided some shields and some guarded gatekeepers who know what they're doing. So if you want to change it, don't go and change it yourself, because that way you'll basically end up shooting yourself in the foot. But if you want to make a change, I'm the creator of the class, and I'm not going to visit every time an object is created. It has my phone number, so I can kind of call Rizzo and say, hey, I got an object, I want to change the name. I don't want to be, accompanying every object that I create, but I will give you 2 of my prized employees, right? They're called setters. Okay, well, setters, you can use those setters and tell the setter to do it, and they have my permission, right? Because I told them how to do it right. Okay, so you tell the setter to set a value, they'll go and set the value for you. You can't set it direct. Now that is a controlled way of giving access to your object, and that is how your object becomes useful to the external world, is that it has some public things that people can see, it has some private things that people cannot see, but it also has methods. They're called methods in the object that know how to go and change the private things if you want them to. So we're going to go and create some methods. But do the methods need to be private or public? Can someone say the methods need to be private or public?
I think public.
Public, right? Because these methods are, how do I change? Yeah, okay. These methods need to be called by other people, right? And these methods can't be private because outside of the class, people need to be able to call those methods. So now let's create another public section under private, right? Yeah, in fact, let's do another one, brand new one, so that, it's familiar, so that everybody can see clearly that you can have multiple private and public sections, right? People do that.
Before we
sometimes separate that multiple.
Before we jump into that, can I ask a quick clarifying question?
Sure, go ahead. Yeah.
So when we set something to public, people can still see the name. So for instance, right now, name and favorite food are public. People can still see the name and favorite food, correct?
They can, totally.
Can they still, can they change it?
They can.
So on line 19, where we change pet age to 4, if we took that out, would the program compile?
It'll work. Trade out just now. Right, comment it out. Rizzo, comment out line 19 and compile it and run it. No, not there. Put the double slash in front. Yeah. Okay, now it'll compile and run. No, there's an error. You didn't save it. I think you didn't save it.
Well, because we're still using pet age. So
Yes,
that's my follow-up question is,
I see.
pet age
you're
is
using it. Okay, then I'll show you how to do it.
So then the follow-up point is, then on this private side, not only can we not edit it, but we also cannot use it.
You can't see it. It's private. Yeah.
Okay. And that's why it doesn't compile, even though we took the editing of pet age out, because we are still trying to see out pet age. That's why it won't compile.
Yes. Thank you for asking that question, because that one didn't come out at all in the previous.
Yeah, because I was thinking there's definitely there's the aspect in, like, if you think about almost like a text document, there's read only, and then there's completely private where you can't even read it.
That's right. It's like a black box.
And so right now we're kind of dealing with public is completely open where you can read it and write to it, whereas private is completely private where you can't read it or write to it.
Yes, okay. That's right. And I don't believe there is a way in which you can you can read but cannot write. I don't think there is read only.
So there's
qualification.
No way. Is there?
Oh, there is obviously.
Another way to frame it would be like, is there any way we can hard code variables to an object?
Yes, there is. Yeah, and we'll cover that. I'm thinking when we should do that. You can have static constants inside. You can have constant variables inside of a. We'll cover that next class, okay? So, because this, I think it'll be easier to introduce after we've done some experiments today.
I think we talked about it briefly in a past lecture, but only briefly.
Who talked about that?
I think we did very briefly.
Today?
No, we talked about it. We talked about it when we were talking about multiple. I think it was like 2 or 3 lectures ago. We talked about maybe not the exact idea, but something similar. We talked about how we want a variable not to change when we.
Passing by reference. Passing by
Yeah.
reference.
Yep.
Yeah, I understand. Yeah, I remember now. So yeah, it's very similar, right? You can have a variable in an object that is const, which means that it can be read from, but it cannot be written into.
Actually,
Yeah, and we'll do that. We'll do that later.
could you not just have a constant pointer to a private variable to act
No, oh, I see. You're saying have a public pointer. Why don't we try it out? So that's the best way to try it, right? So why don't we try it out? No, not right now. Daniel, can you remember that? We'll be in a much better position to experiment with that in, I think, about 5-10 minutes from now. Yeah, can you bring it up again?
Okay, but I can't guarantee my computer's really acting up, and I.
Okay, all right. I'll try and remember. Okay.
It for a while.
So let's make a few more
but
changes.
Also, if I drop out of the meeting, it's probably because I'm trying to get my computer not to crash.
All right, don't worry, Daniel. I think you'll be fine. Okay, but and if you drop out, welcome to join back anytime. Okay, so we'll continue to make some changes here, and we'll thereby address both Daniel's and the point that Andrew made here. Okay, all right. So now what we're going to do is create some methods that will allow us to manipulate things even though they're private, okay? So after age, insert a blank line, maybe one more blank line, and say now we're going to start declaring methods, right? So say public. Yeah, so yeah. All right, so we're starting another section of everything that is public, except here they are not variables. We're going to create functions, functions that are attached to objects. Then they're called methods. Okay, so the first method we want to do is called get name. All right, so and it is going to return a string. So get underscore name will return a string value. Right, so open close. Yeah, there you go. No, it's not. It's going to return a string. It's not going to take a string. It's going to return a string. So the string qualification goes before get name, right? Before the G, say string. Yeah, string and then one space. I think you got 2 spaces there. Okay, so when get name is called, it's going to return a string. Now, here's a very good thumb rule and good practice, okay, remember, and it's not going to break your program just because you don't do it, but I highly recommend you do that. Now, when I call get name on an object, is it going to change the value of name?
Yes, I think it can change.
No, I'm just calling get, oh, I see, we haven't completed the name. Okay, all right, so space, say space, right there, space, not there, after the closing parenthesis, sorry, space, yeah. Open curly brace, a space, and on the same line actually. I want to say because we'll do what you are yeah shortly. You got 2 spaces there, I think, just 1 space before the brace. Yeah, and then yeah, say return name. Yeah, return semicolon. Right, and you can actually put the whole thing on the same line as the get name. This is called an inline function. This also works, by the way, but but you will end up doing it this way yourself after a little while. Okay, yeah, thank you. Thank you, that's all very nice. Okay, so that's called an inline function. Now do the same thing for, I think you're missing a space to be symmetric on this side.
Yeah.
Okay, all right, do the same thing for favorite food and age also.
Can I say just
hit type F and hit tab? Yeah, no, I think good practice to name it exactly the same as the member. The reason I say that is because you'll get to a point very soon where you can have the compiler or an IDE generate these getters for you automatically. You don't have to write them. The compiler will generate it. And if the compiler generates it, this is the kind of name it will create by itself, right? So it's better for us to also get in the same wavelength as the compiler. So get favorite food and then return favorite food. Is everybody following along, by the way? All okay?
Yep.
Thank you. All right, and do the same thing for age.
Are semicolons necessary for inline functions?
Yeah, well, semicolons inside of the
The
brace.
method? Yeah.
Yeah. They're just regular functions, right? They're regular, nothing else different. Okay, now where you reference the variables in main, right? Under age, right? The first two are public, so you don't have to care. Under pet.age, get rid of the line number 24 because it's private, right? Oh, actually, you know what? Yeah, comment it out for now. And where you're referring to mypet.age on line 26, replace the .age with .getAge. It needs to be a call. That's method you're calling, right? So you're going to say, yeah, there you go. Your cursor is in the right place. Open, close.
So I should delete my pet.
After age, yeah, open, close parentheses, right? Now you'll find that it works, except it'll print 0 for age because it hasn't been initialized, yes? So run it.
Okay.
Oh, you got a spelling error.
Sorry.
That's all right. Okay, so it worked. Actually, see, there you go. Here, funny thing is, I thought in C++, initialization of variables by default, the default int value is 0, but obviously it didn't set it to 0. It's probably because it's part of an object. But anyway, so what we need to do is we never set it to any value, right? So it's printing junk. So now we want to go ahead and create what are called counterparts for these getters. These three methods that you just wrote, they're called getters because they go into the object and get stuff that's in there. Now we're going to create 3 more methods just like that, but they're called setters. Setters will go into an object and change the value, right? So now insert a blank line after the third getter, and we'll create 3 setters. Create 3 setters right there. And these setters are going to take values and set the internal values. I'll create the first one for you. You can create the remaining 2. Yes? Is that okay?
Okay.
All right. Give me a blank line there. One more blank line because it's, it's getters and setters who will prevent. Yes. All right. Now it's a setter, which means that, first of all, let's start with a void signature. Say void set name. Now set name is going to take a parameter, right? Set underscore name.
Okay.
Yeah. It's going to take a parameter because it needs to take something from you and set it in the object, right? So it's going to take a parameter, take a string parameter and call it name. Yeah. Okay. Now open and close. Yeah. Oh yeah. And inside of that, you're going to say this dot name equals name. Now what that means is that, well, we'll get to that very soon, right? Equals name. Okay, now semicolon. Now we're going to make a bunch of changes here, right? And stylistic changes, but they're important stylistic changes. I'm trying to motivate it by setting up for it. Okay, now go to the place where you have mypet.name equals Laska in main, line 24. And then say mypet.setName and pass Laska as a parameter.
And what?
Pass it as a parameter to that method, right? So you're going to go set name, open parentheses, not there. No. Set name, open parentheses, because you're just calling that method, right? And pass it Laska. All right.
Is that all?
Do the same thing for favorite food also. The whole damn thing for favorite food, right? So you got to create the setter also.
Yeah.
Create the setter for, yeah. And if you want, create the setter for age also right there while you're in the same area. It's the same place, right? Create the setter for age also.
Food. And
Yeah, go ahead. Do age also. Age. Create a setter for age also. Okay. Right now, change those, and then now you can put in your age setter also. Yeah, there you go. You know exactly what you need to do, so you're doing it already, which is cool, right? Okay. Equals lettuce. All right. Okay, now set the age.
it was 4.
Okay. All right. Run it. And it should run.
Line 18, it should be set favorite food, not favorite name.
Oh, yeah. Thank you. Who was that? Momo?
Georgia.
Giorgio. Thank you. Everybody, everything else okay?
Yeah, it seems
Okay.
pretty good.
All right. Now you should be able to run it and it would compile and run.
But we still have an error.
What is it? Request for member favorite food, which is of type, which is a pointer type. String favorite food, return favorite food. I'm sorry, where is the error? Line 17. Okay, oh, set name, string name. Why does it say there's an error on line 17? What is the error? For member name, which is a pointer type pet. Wait, does it say it's type pet star? Yeah. Oh, I'm sorry. Jeez. Okay. All right. So this dot should be this arrow. I say in Java and Python it's always dot, but in C++, if the object is a pointer, then you use an arrow. But we haven't covered pointers yet, so it's kind of it's kind of strange. It's kind of strange, right? Because people usually learn C++ after learning C, so they already know what pointers, and that's why I think. All right, so you got to turn the dot into an arrow, dash greater than. Okay, it's a dash greater than. Dash hyphen.
Okay.
Greater than. Yeah, see, that's an arrow symbol, and that says inside of my pet class object, there is this field called name, get it? But this object that I'm giving you, I'm not giving you the object itself, I'm giving you a location of the object in memory. So what the word this, right? THIS, this, what does this mean? This is a free parameter given to you. Every method that is called on an object, this is a parameter that gets given to you. Without even, you see it, you don't specify it. It's not in the list of parameters, right? It just gets given to you implicitly. It's an invisible parameter that's given to you, but you can always access it by using this. THIS is the name of that parameter. And arrow means that parameter is actually a pointer, and the pointer is a complex object. So take the pointer, go to where it is in memory, and inside that you'll find name and so on. So that's what the arrow means. Okay, it takes a little bit of getting used to. I don't know how long, because it's quite a while since I got used to it, so I forgot how long it took me, right? But you'll find out. Okay, turn on. Yeah, now it should compile and run. All right. So
Yes.
if everybody is on the same page as us right now, we can go on to the next step. We're going to make more changes here. Now, Rizo, if you are, what time is it now, by the way? I can look at your clock. Your clock is like different time. Okay, we've got about slightly less than half an hour left. So I would like someone else to take your code, and then is that okay, Rizo? You can come back. You get another opportunity later on. Okay.
Okay.
All right. So copy that entire thing, put it in a collaborated window. And who was the next one who wanted to come up? Someone volunteered before. It was Rizo first, and then who else? Come on, guys. I'm scrolling back here in the chat window. I can't find it. Was it Flavio?
Yeah.
Yeah. Okay. Why didn't you speak up? I asked who was next. All right. You want to go? Oh, you did say me. All right, go ahead. So pick up the code from his collaborated window. Rizo, you know how to do this in collaborated?
Actually, can I share a REPL link?
Yeah, fine. Go ahead. If it's REPL, there you go. Hey, Flavio, pick up that REPL link and then share your screen, and then we'll make more changes right now. This is coming along really nicely, right? Some of the important concepts are being covered well, and then I think we'll also take exactly this code and continue working on it on Thursday, right? Because the other concepts that I wanted to cover with objects, we can still use the same thing. All right.
So can I just clarify something real quick?
Yeah, sure.
A concept. So even though age was in private, if we use a setter, you can still change it.
Yes, because private means only the external world can see it. You can still see it, right? Now, what do you mean? What do I mean by you? What I mean by you is not you as a programmer, the pet object itself, the class and the methods that are attached to it, they're all family members, right? Anybody in the family can access all the private members, okay? If you go outside the family, they can't access the private members. Does that make sense?
Yeah. So
the get, all the get methods and the set methods, they're all members of the family, so they can access all the private parts.
Got it. Okay.
Okay, so who is this now? Flavio, it's your screen. Flavio, are you controlling the screen now? I can't. Yeah, you got to speak up. You got to unmute your speaker or something. Hey, Flavio.
Can you see my screen?
Yeah, I can see your screen, but I don't think we can hear you, or at least you're not talking. You're speaking up, maybe.
Oh, can you hear me now?
Yes, can hear you.
Right.
And yeah, everything is going okay. All right, so here's what we're going to do. Now, you see that when you call the getter, are the getters actually changing the object? Now, I say, my pet dot, see out my pet dot get name, right? And then I call it 5,000 times. Each time I call it, is it going to change? Is it going to give me a different result? Is it going to give me a different result or the same result? Same, right? So what it means is that method that I just created and made available to you to look inside, it's basically a window into my object, right? You can reach through the glass panes and change the object, but you can look through it, right? That's your read only. So that getter is what I would call a constant method, meaning a method that can see inside but cannot change inside. All right. I think this addresses one of the questions that Andrew or someone brought up before. And correct me if I'm wrong. Yes. So does that make sense? Okay. So we are going to tag the get name method with the word const, right? So say const after get name, const. Not there. So that you put a const there, if you would say that, get name returns something that is a constant. No, you want to say get name is a method that does not change the object on which it is working, right? So the const needs to go in a different place. So here the const usually goes at the end of the method declaration, not there after the parentheses,
So
Yeah,
here.
space const. Okay, so if you put a const there, it means that the compiler now says, okay, the getter will do its job as usual, but inside of getter, I'm not going to let this method change the name. Okay, so now try and run it, and it should run. Okay, make all the getters const, by the way. All right.
Oh.
Yeah, that's fine. Make all the getters const. Okay, now run it, it'll run. Great. Okay, so it runs, right? Now inside your getter, what permissions do your getter has? Do your getters have? They can read but not write. Okay, like Vegas, see but not touch, or something like that. I don't know, right? Never been there. I don't know why. Okay, if you see the cards, you can. Anyway, so there we're going to try and change it. In the getter, you're going to try and change it. So inside of the getter, get name, right? Try and change the name before you, says instead of returning the name first, before you return the name, change the name to something you want, right? Say name equals Giorgio or Flavio or something like that. Name equals. So here, right? So the getter is doing something bad, yes? Because the name getter says, I'm just a getter. I don't know. I don't do anything else. You ask me something, I'll get it for you. That's all it says. But secretly under the covers, it's doing something that it's not allowed to do, right? It's trying to change it. When the programmer said it's const, it's not allowed to change it, it went and changed it, right? So try and compile it and see what the compiler says now. Oh, yeah, I don't see the, where is it? Can you see the error message?
Yeah.
Right? So there, there you go. In error message, line 13, it says, hey, you're trying to change name, but you can't change it because this method is a const. Well, the error message is really freaky, but that's really what it means. Actually, it does say the right error message below, right? You just need to be not scared away, right? Here it says, the function is not viable, meaning I can't use this getter because this argument, the object, is supposed to be constant. You're not. It says type const, but you're trying to change it. That's really what it's trying to say. Does the message make sense to you? Yes.
Sure.
Yeah. Okay. So you're trying to change it, and it doesn't let you change it, right? But if you remove the const qualification, it'll let you change it. Now, you can try it out if you want, but you try it out. It doesn't try it out, right? Now try and change it. Now run it. It'll run. Why did I know? Why did it say you're not using the getter later? Are you not using the getter when you
No,
in the
that's
C
not
outline?
using the get.
Yeah, use the
No,
getter
but-
everywhere now. Yeah. There. Okay. Okay, now run it. Oh, my chat window covers up the console, so I don't know. There you go. My pet is 4 years old. My pet Spot is 4 years old, right? So you managed to change it, right? So and it works, right? It's now. Does everybody understand the nuances, right? So getting getters and setters and everything, working is just the first step, right? There's all these nuances that you need to know and leverage at the right time, and that's what makes it really powerful and strong. In that, now you see by using the const keyword there, you can make sure that not only is this method not allowed to change Spot and then change the object, in fact, it is not even allowed to call another method which will change the object. Okay, so let's go ahead and create this, right? Create a dummy method above main, right? Create a dummy method. Yeah, make that const above main. Create a dummy method. Call it dummy. Void dummy. Right? Blank line there. Blank line. Yeah, void dummy. 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 And then
Yes. Oh, yeah. Oh, wait.
dummy, yeah. And then it is going to take a parameter that is passed by reference, and it's a string parameter that you pass by reference, okay? Or age parameter passed by reference, okay? So you say int ampersand age, or int ampersand a, or something like that, right? N, int ampersand n, ampersand, not hash. Ampersand is that and thing.
Oh, okay.
And yeah, that's passing by reference. N. Space, space, n. Okay, now in the body of this method, say n equals 10. Yeah, okay. Now, in your get age, right? Get age, just call a dummy, right? Call the method dummy and pass it the value, pass it age, right? Pass it age. So call, say you say set age, because it's a global function, right? It's a, set underscore age, and then pass it this arrow age. Open parentheses. This arrow age is the parameter you're passing, right? Not there, inside the parentheses, because this arrow age is a parameter you're passing to that function, right? So this arrow age, semicolon, equals 10. Oh, no, I'm passing it, sorry. Yeah, and then after the parentheses, put in a semicolon and a space. Not there. No, there you're just passing it. After the parentheses, you put in the semicolon and the space.
The what?
Get rid of the blank, this is space, and then the semicolon, and then the space after that. Get rid of the semicolon. Yeah. Get rid of the semicolon. Okay. Now go before the R in return. Before the R, yeah, semicolon there, and then a space. Okay. Now what's going on here is that when you call get age from your main, get age is going to call another function called set age. Not set age, and dummy. You want to call dummy there, not set age. You want to call your function called dummy, right? And one thing you need to do is, because you're calling a method before you have created the method, you need to move the declaration of the above. So cut the line 22. Cut line 22 and put it right up there after the namespace. No, cut, yeah. Okay. And get rid of the blank lines. Yeah, put it there after, yeah, blank line there, and yeah, put it there. Okay. There you go. Okay. Now get rid of the const qualifier on get name, right? Because that will prevent it from compiling. And get rid of the name equals spot, right? Because we're not trying to do funky things here, because that's, yeah. Excellent. All right. Now, if you try and compile it now, the compiler will still complain. This is incredible, isn't it? Right? And look at the sheer power you're getting here. You're going to compile it now. Get age is tagged as a const method, which means it promises the compiler, dear compiler, you can call me. I am not going to change the object. Okay. And you look in the body, it's not changing the object. However, it is making the fatal error. Okay. A fatal mistake of calling some other method inside of its body, and that method does not promise that it won't change its parameter, right? And look, dummy is taking the parameter passed by reference, which means it is able to change the actual parameter, not a copy of it. It's able to change the actual value. Now, the actual value being passed is the age, and the age is inside the pet object, and the pet object is not const, right? So if the compiler is clever enough, it'll pick up the chain. So main is calling get age is marked const, which means it cannot change the pet object, and get age itself does not seem to be changing the object. However, it's calling another method, and that method might change, right? So there's this chain, and in this case we only have a chain of one, right? So you're calling get age, and get age calls dummy. But imagine a more complex function, right? A complex method in which you're not just calling one function, you're calling many functions, many methods in that method, and those methods call other methods, right? So you can quickly imagine how big of an enormous forest this call tree will become, right? So the compiler gives you that promise saying, don't you worry about any of that. I'll track it for you, right? I'll track it for you. You tell me if this object is const, and I will make sure that no matter where this object goes, you can give the object to someone, they could give that object to someone else, and they could pass it in a million hands, change hands a million times. I will make sure that nobody who has their hands on this object will be able to change it. Okay, that's what the compiler tells you. Now you try and compile it, it will tell you that, no, I can't call dummy from here because dummy will change it, and then the designer of the pet class said, get age cannot change dummy. Compile it and it'll complain, right? It'll complain. Right? So it says here in the error message, this is a candidate function is not viable, right? Because the first argument would end up changing, it'll lose a const qualifier, right? So if it wasn't const, it'll work, but it's got const, it won't work. Does that make sense? It's a very subtle point. It's a very subtle point, but you'll exploit it like a million times when you start coding, power coding. This is all important, very important and useful. So now, is this clear and useful so far? Because before we go on to the next step, I want to make sure this is all nailed down.
Yeah.
Okay, great. So we're going to make one more, a small change here. Now, you notice that all our setters are basically void methods, right? So in other words, you're telling the setter, go and set the name to spot, right? Go and change the, the favorite food from, meat to cabbage or things like that. But you don't really know if it worked, right? What happens if you're raising a lion called Lasco, right? Lasco, really cool name, right? You say, oh, my pet called Alaska. She's gone to Alaska. What's her favorite food? I don't know, Alaska, all right? So you want to change the favorite food to from meat to cabbage. And you don't know if it's going to work or not. But as a creator of the pet class, right? As a user, I don't know. But how can you make it so that even though I use your method, I will know, right? What if I say Lasco.set favorite food to cabbage, right? And it's a lion, doesn't like cabbage, right? And say, no, I don't, that's not my favorite food, right? So the setter will say, no, I can't do that. Because your setter is a filter, right? It's a guard, your gatekeeper. You'll say, no, this is an illegal value. I'm not going to set it. But the function does not indicate that back to the user, the caller. So the caller needs to know getters, no problem, right? Getters cannot fail. Getters rarely fail, right? Very, very rarely. When you ask for something, all it needs to do is read only, get it and give it to you, right? So it cannot fail. So it doesn't make any sense to make getters signal you saying I failed, right? But setters can fail. Setters can fail if the value you're giving them is illegal. And you need a way for the setter to tell you that it failed. How can you know, right? So in order to get away, we're going to change all the return types from void to bool. Okay. Now, Flavio, by the way, there was one other person who wanted to go after you. I don't know who that is. You cannot access the methods before you define them, right? So you can call them Bile. There was a question Bile asked, right? So if someone wants to go after Flavio, take the REPL link, and if Flavio is okay, you take over and I will continue. We'll continue exactly like this, but someone else will be doing the typing in. Are you okay with that, Flavio?
Yeah.
Okay. Don't give up yet, right? Someone else who wants to take over from Flavio? We got time to make these last changes too. Can you please pipe up and speak? I'm finding it really hard to look through the chat window here. Who wanted to go after Flavio? There were 3 people at least. Nobody?
You want me to remind you to try. I am using a pointer to constant in memory as a pseudo getter.
Oh, wait. Hey, Daniel, wait. I want to make sure that there was someone who volunteered. Someone who volunteered and now is backing out. Have you disappeared from class or something?
He typed it in the chat. I think it's Bayo.
Right. Okay, Bio, take over the screen. Okay, you got to speak up. Okay, I told you that. I'm not listening to I can't see the chat window at the same time as doing this. When I say speak up, you got to hit the space bar and speak up. Okay, all of you. Okay. All right. So whose screen is this now? No, this is mine right now. So take over. Bio, take the screen. Click on that link that he sent. Is it the same code? Yes, it is the same code. Okay, now we're going to change all the void returns for set the setters, make them all Boolean returns, right? Make all the setters Boolean returns. So where you have the signatures, line 17, 18, 19, make them all return Boolean values, true or false, right? Change the void into bool. All the 3 voids must now be bools.
Where?
Bool. Void on line 17, VOID, change that to bool. Double click and say bool. Double click on the void and say bool. Yeah. Okay. Now there is a way, right? We haven't done it. We haven't completed it yet. Now we have just set up a way for set name to signal back to us if it succeeded or not, right? Because if it succeeded, it can return true. If it failed, it can return false. That way, in my caller, in my main, here, there you go, right? On line 26, go to line 26 at the beginning of line 26, right? At the beginning, before the M, you can say if, open parentheses, go to the end of the line. No. Just open parentheses, not closing. Yeah, you got 2 spaces after the if too, right? Right, and then yeah, brace, yeah, brace, curly brace. Yeah, enter. Now you can say cout successfully set name. Cout, yeah, successfully set name. Right? New end line. Yeah, okay. And then you want to else say failed to set name. Right? Okay. Yeah, you need to, at some point later, you need to make it more consistent to the styling, right? One of them has braces on a different line than the if and the else, but never mind. You can do that later, I guess. No, yeah, there you go. Okay, all right. Now go back to your setter up there on line 17, and here you're going to say if the name that is passed in, if inside, yeah, if the name that is passed in is not an empty string, then you set it and return true. Or rather, the better way to do that is if no, yeah, this arrow. No, not this. No, if the name that is passed in is a parameter, not this name. Yeah, if name double equals empty string. Empty string. Yeah, you just return false. You don't need braces there. It'll be easier. Yeah. Return false. Right? Semicolon. Now everything else after that will only happen if name was not an empty string. Yes. Now you can set this arrow name to name and then return true. You got to return true at the end, right? Because now you're successful, right? Return true. Right. Semicolon. All right. Now if you run it, it'll set the name successfully to Laska. Right? Run it. Compile and run it. So, right now, try and set the name to an empty string. Try and set the name to an empty string where you call it. Yeah. Does that make sense? Is everybody clear on what just happened? Now it failed to set name because now here's the well, we'll make some cosmetic changes now, right? Which makes it easier. What time is it? We just need to make some cosmetic changes and then we're done. Can you guys stick around for 5 more minutes? We're almost done. We just make some cosmetic changes, the important cosmetic changes. Okay. Well, and keep the code and remember this URL. Okay. We're going to come back to this code on Thursday. Now, the cosmetic changes is now you see that setter, the name setter, right? The function is not just trivial. The getters are trivial, right? Because it's just one line and it's one statement is all done. The setter is not trivial, right? It does a few things, one more. So really, you think in your mind that it's going to be more aesthetically pleasing if the setters are not inline, not inside of the class. So let's take the set name for now outside the class and declare it out of line. So triple click on that line, triple click on that line, and Control X for cutting it. Control X or Command X. Control X. Okay. Now go outside of pet, right? After just before main. Yeah. Enter blank line. Okay. Now paste it. Command V. Okay. Now get rid of the space before bool. Okay. Now because it's out of line, you need to tell the compiler that this method that I create is part of the set class, not a global free-floating method. I want you to attach it to a pet class. So to do that, you go just before the S in set name, go before the S. It's a pet, P-E-T, uppercase. Yeah, double colon. Now it's an out-of-line method. It's exactly the same as before. It's just for aesthetic reasons we pulled it out, and also said even though it's outside, it's part of the set class. That's what the pet double colon mean. Okay, otherwise it's exactly the same. Now because it's outside, you can do a bit more formatting and neatness things with it, right? So move the if statement and everything into the body. Go after the closing brace and bring it to the next line. Okay, yeah, format it as though it's a separate function. Yeah. Okay. Yeah. And then the brace. Right. Okay. Now you see it's a setter. It returns a Boolean. It does validation. This is called validation. It checks the value, sets it, and if it is right, why do you still get this arrow name has got an underline there?
You need curly braces.
Oh, you need to
after
declare
the
it.
if.
Sorry. Yeah. You need a declaration in the body, right? So yeah, copy line 21. Triple click on the line 21. Thank you, Andrew. Triple click there. Copy that and put it on line. Yeah, blank line there. Blank line. Yeah, blank line. Yeah, okay. Group it with the setters. Yeah, and then get rid of the brace on the end. And then the double colon pet, yeah, that should also go. That's a declaration, right? And then and okay, there you go. Thank you. All right, now that should compile and run, right? And then we've done all those things. Compile and run. All right, so that works, right? And then we've also made the cosmetic tweaks. One final cosmetic tweak that I can mention today, and the next class we can talk about more advanced concepts, right? Or we can review this stuff if necessary. Is you see how the name of the parameter that we're using, this is parameter, formal parameter, not the actual parameter, right? We call it name, favorite food, and age, line 13, 14, 15, right? Also 17, 18, 19. The name of the parameter is the same as the name of the member. Now, in that case, if you have the same name, it creates a lot of confusion in the code, right? Because if you use the word name, you don't know which one you're referring to. And the compiler obviously can't tell which, is this a parameter or is it the member? Can't tell. So to do that, we have to disambiguate it, right? And that's what we did here by saying, qualifying it with this arrow name, right? That means name here is the member that belongs to this, not the name that was passed in as a parameter. So you use this arrow to qualify, right? So that is a common way to do this. The other common way that I think everybody should be aware of is to not use the this qualifier, but instead give the parameter a slightly different name, right? So let's try that here. So where you say, where's set name? Oh yeah. Where you say this arrow name, that function on line 22, call it a different name. Call the parameter the name or a name or something, call it X or whatever you want. Yeah, the name, not D name, as D doesn't mean anything, right? THE is very common. People use THE. THE underscore is a common, yeah, like that, the name. Now here you would say name equals the name, right? No, not, yeah, thank you. And then where you say this arrow name, you just say name. Now you don't have to say this arrow. Also, this arrow will also work, but you don't have to anymore, right? Now it'll still work. All right, try it, run. Yay! It works, right? Is everybody okay with this so far?
Yes.
Thank you.
Yep.
Do you guys feel that we covered some useful stuff today? Because we'll come back to this again next class, and we'll take this. We'll do more interesting things. But so far, do you think this has been useful?
Yes.
Thank you. All right. Now, what I think would be really cool is if you guys all take this code. This, obviously this is a replete window and everybody can see it. You should all take a copy of this code and change all of the methods so that you don't have to use this arrow anywhere. Okay? Which means you have to change the parameter name or whatever you do. Change it so that you don't have to do it on screen. You don't have to do it here in class, but in your own time, you have to take the code that, the four of us have written today. Take the code, make the change so that the parameters are not called the same as the members. Okay, make the change, and I think you'll find it a useful exercise to basically nail down the concepts that we've covered today. Now, on Thursday, we'll take this same pet class maybe and create some more interesting methods, okay, to go with it. Or maybe we'll look at static variables, right? Static variables, static members that we can insert into the mix, okay? And that will be interesting. So we covered quite a lot of stuff today, right? And don't feel overwhelmed or anything if you didn't follow along all the way, because we really covered 2 lectures worth of material in one class, meaning that we can go over it and then go over it more times next class if necessary. But ideally, this is all pretty straightforward. You should be able to get to it. Ask questions in the forum on Reddit if you're necessary, under building blocks or tips and tricks. Building blocks really, and we'll all try and clarify on Slack, one of those channels that Andy and Andrew are on it to help you guys all the time. Giorgio, many of you guys, right? And there's a lot of you that I can see who are clued up already and happy and really looking forward to help people, right? Now you guys know how difficult it is, right, to get people to come and ask you for help. Everybody's so shy. And I know you guys are on the Slack channel and you're advertising, saying, hey, come and get help, and people are not coming. I don't know why. Well, they are. I think I'm not there all the time, but people are shy, or maybe they just have too much conflicting demands on their time. But still, if you want to be a programmer, if you think you want to be in the Silicon Valley earning a living by practicing the craft of programming, you have to go. Otherwise, C++ is just going to be a footnote in your life. I happened to learn C++ for 12 weeks in my life, 75 years ago. If that's what you're after, I don't know. Then this whole course becomes like a Netflix movie, right? You did for entertainment at some point, and then you've forgotten. You want it to be part of your life, and so you can create stuff with it. And I think this will set you up. All right, can you all do what I suggested later on today? Right. Also, the only way I can know if you guys are benefiting from all this is if you chime in, right? If you chime in the YouTube channel under the video saying, hey, at 34 minutes, there was this program, Flavio, go and look at it. And we talked about objects and so on. Summarize it even, right? Summarize what we did. What I say in so many words with 10 or 15 minutes of your time, talking about something that you can easily say in one sentence. Right, and say, oh, at 53 minutes into the lecture, Anand talks for 100 minutes about this concept, which I can summarize in one line, right? So you can either watch from 53 minutes or just read this one sentence that I've summarized. And you can make that point right there. And I think it'll be useful for everyone. All right, so I hope you guys have a great time. And for the rest of the day today, and I will see. Are you guys coming back on Thursday? I hope, and I will see you there. And thank you so much for your time.
Thank you.
Thank you.
Thank you.
Send me ideas. Send me ideas, okay, of things that you want to talk about next class, projects that you want to do, little program stuff that you'd like every one of us to get into and code. All that stuff, send me a email, and then like today, we don't have to pick something off the top of my head, right? We'll just pick up the idea that you have sent me. All right, thank you, Sumaid, Bio, all of you. All right,
Thanks.
I'll see you guys in 2 days' time. This is week 7. This is week 7, right? Yeah, wow, time really flies. All right, I'll see you guys soon. Best of luck for the rest of your week. Bye, guys.
Bye.